Hey, we have here today another integral from the UNT Integration Bee. This was sample problem number 24. We have the integral of x cubed e to the x squared dx. Okay, and the first thing to start with what I want to do is I want to look at this x squared. We want to do something about that because that tends to make a indefinite integral kind of complicated. And so for that, what I'll do is let's try to handle that with a u substitution. I'm just going to make my u equal to x squared, knowing that if we get this to e to the u, it's going to make things pretty easy. And then we'll just take a derivative to find du, and that's going to be just 2x dx. And what I'm going to do now, before I substitute actually, I'm just going to kind of rewrite this and set it up to make it easy for myself. I'm going to try to get it into this form. So what I can do is create an x squared here, and we get this 2x dx. If I put this over here, this is going to be my du. But if you multiply 2x times x squared, you get 2x cubed. So what I need here is a half. So that if I multiply this together, if I multiply a half x squared times 2x, then I'm back to my x cubed, and now we haven't changed it. So then I'll make my substitution. I'm going to bring this 1/2 out front first. Okay, so we'll write this as half up front. Our x squared is just u. This thing is going to be just e to the u now, and then this thing is du. And what we have here is kind of a perfect situation for integration by parts. I'm going to do this using the DI method, tabular integration. I'll make 2 quick columns. We'll have one column here to differentiate, one to integrate. I definitely want to differentiate u, and that's because the nice thing here is when we differentiate this, it's going to differentiate to 0, and then I'm going to integrate my e to the u. So then differentiating on the left side here, derivative of u is going to be 1, and then derivative of 1 is going to be 0. That's nice. Then integrating e to the u is just going to be e to the u, e to the u. Then we'll have part of our solution here on the diagonals in u, of course. And so when I write this, since we have eu in both these, I'm just going to factor that out. And let's not forget this 1/2. So I'm going to write this as 1/2 e to the u. And then here we're going to have just u minus 1. Now this last column would be an integral, but because we have a 0, multiplying 0 times e to the u, integral of 0 is just 0. So we're going to ignore this part. And let's just take this piece here, and we just need to back substitute. We just need to bring our u back. So doing that for our final solution, we're going to just have 1/2 e. U again is x squared, so we're going to have e to the x squared, and then we're going to have x squared minus 1 plus c, and that's it. Anyway, so that's the last one from the UNT Integration Bee. We'll move on to something else now. Thanks everyone for watching today. Have a great day.